Hello everybody, I'm Nick, and for the past few months I have been publishing .NET tips in my YouTube channel in the form of shorts, because something does not necessarily deserve an 8 or 10 or 15 minute video, but in 60 seconds I can teach you everything there is about a short actionable tip that you definitely need to know about. Recently I hit the 100 tips mark, and many of you said, Nick, make a compilation video that just contains the first 100 shorts. And that's what this is. We reorganized them a bit, add a bit more context, and this is an hour-long video containing every single tip from 1 to 100 for your enjoyment. That's really it. Enjoy. 1. When dealing with collections like arrays or lists in C#, it is very common that you might need to return empty results, for example, when no entities of a specific type exist in the system. Returning an empty array like this, or an empty list like this, will actually allocate an empty array or list on the heap every single time it's invoked. Even if it looks small, depending on your app's throughput and how often you use it, it will add up, and it will cause the garbage collector to clean that memory, leading to app pauses. I've seen many people cache this empty state on a field or a property, and that will fix the problem, but there is actually a better solution. For arrays, you can simply use Array.Empty, and for other enumerables, you can simply use Enumerable.Empty, and this will guarantee that the empty collection is only allocated once throughout the application's lifetime. 2. Are you sure you're rethrowing your exceptions correctly? In C#, it is very common to catch exceptions. This is usually done to analyze the exception content, maybe do something with the exception type or the message itself, such as login or metrics collection. After the analysis, it is a common practice to rethrow that exception because you might want to get it caught by a centralized exception handler or some filter that translates the exception to a special response. There are two ways to do this, and one of them is completely wrong. If you're rethrowing it by using the throw keyword followed by the exception variable name, then you are shooting yourself in the foot, because this approach completely ignores the exception stack trace, which is where a lot of the useful information lives. To prevent that from happening, simply use the throw keyword followed by nothing. That way you're rethrowing the exact same exception that you caught, including the full stack trace. 3. Locking is a technique in C# that allows you to wrap a block of code with the lock keyword, ensuring that only one thread can access that piece of code at a given time, which can be really useful in multi-threaded applications. There is a catch though. You cannot use the lock keyword with async await, which in today's day and age makes it way less useful since many C# scenarios use async code. There is, however, an alternative. You can use a semaphore_slim class to implement the same locking behavior. Simply create a new semaphore_slim object in your class and specify the first parameter with value 1. Then when you want the locking to begin, await the wait async method of the semaphore and then add your code that is now locked. After you're done, simply call the release method. Because we specified that one value in the semaphore's parameters, only one thread can access that block at a given time when the semaphore is waited. It is also a good idea to call that release method in a finally block, guaranteeing it will be called no matter what, preventing a potential deadlock. 4. C#'s Linq is an amazing tool, but it has a huge but not so obvious performance trap. In this code, I'm building an enumerable that contains the numbers from 1 to 10. First, I'm getting the count and I'm printing it, and then I'm checking that all the items in the enumerable are positive. This code might look fine at first glance, but now let's add a console write line in that select method. As you can see now, both the count and the all methods trigger a print. This is because our enumerable is enumerated multiple times. This is extremely bad because we allocate the collection and we do all the work needed to build it twice, which depending on the workload can destroy your application's performance. And yes, depending on how the method is written, this could also cause multiple I/O calls on things like databases. To fix this, simply enumerate the enumerable as an appropriate structure like a list or an array and then operate on that. 5. Ever wanted to quickly check what a piece of C# code would return, but you were too lazy to open your IDE and create a new console application just to check it out? Me too, but you no longer have to. C# REPL is a cross-platform command line tool that allows you to run C# directly in your terminal of choice. Simply install it globally using the .NET tool install command, and voila! You can now run the C# REPL command anywhere and enter C# mode. Not only do you have full IntelliSense support with autocomplete and suggestions, but you can also install NuGet packages and try out something that isn't even in the BCL. You can go as far as running it against ASP.NET Core and running a full API directly in your console. 6. We all know at this point that if you want to work with an array in C# as fast as possible, then you want to use the span of that array. But that's pretty useless when working with the most common collection type in C#, the list. In C#, every list is actually backed by an array, but that array is inaccessible, so you can't use it to grab its span. What you can do, however, is use the collections marshal class and its asSpan method. This method will allow you to grab access to that internal array of a list and use it for any operation. Be very careful, however. Grabbing the span this way is unsafe, and if the list is mutating while you're iterating over it, you won't get an exception as you would normally do. 7. Logging is a fundamental of every application, but there's a big problem with it in .NET. The built-in .NET logger refers to the text part of the logging as the message. However, that is a lie. The text parameter of the logger isn't actually the message, but rather the message template. If you're using string interpolation, string formatting, or string concatenation with your logger, then you are doing it wrong. Not only do you lose all the parameters of your logging method, making it impossible for you to filter your logs, but also you waste a ton of memory in strings that need to be garbage collected, slowing your application down. Simply name your parameters with a descriptive name as part of your message template and provide your arguments as a second parameter. This prevents all the memory issues and makes filtering a breeze. 8. C#12 introduced a secret feature which no one has talked about, including Microsoft, and it's what I call empty types. For years now, you could define the type like a struct, a class, or an interface and leave it empty, but you still needed to have these curly brackets hanging around for seemingly no reason other than to make your code look ugly. People did this, or this, and even this, but C#12 introduced a new solution. You can now simply omit the curly brackets and add a semicolon, and voila, your code compiles and your type is nice and empty. 9. Should you use ToList or ToArray? From a functionality standpoint, it's all about what serves the use case best. Is the consumer going to mutate the enumerable by adding or removing items? Then return a list. Is the consumer going to simply enumerate or mutate existing values in the collection without actually changing its length? Then return an array. From a performance standpoint, things are a bit more complicated. Since list is just an array wrapper with some magic around it, you'd think that ToArray is faster, but it's heavily depending on the collection size. For example, for 10,000 items, ToList is slightly faster than ToArray, which is really weird. However, .NET 9 brings performance update, which makes ToArray a lot faster than ToList. 10. Ever used libraries like Mediator or Automapper and had to register them in dependency injection using a method like this one? Then you might have noticed that these methods accept a generic type. This is a type which lives inside the project, so the libraries can identify the marker and register things on your behalf without you having to do it manually. We call that type an assembly marker. People usually use the program.cs file there, but in my opinion, that's wrong. What I like to do is make an empty interface named after the assembly it lives in, and then use that. This doesn't only remove any ambiguity regarding the purpose of the type, but it also makes my code more readable because I know exactly what is being registered, where, and for which project. 11. Ever wrote a method that uses a string to represent regex, dates, URLs, or even JSON? If you have, you'd know that if you pass any of those types as a parameter on that method, they will be formatted and highlighted as simple meaningless strings. .NET 7 finally fixes that problem. You can now use the StringSyntax attribute on the parameter and specify what the text is meant to represent. Once you do that, your IDE will take that into account and highlight the text appropriately to give you a better developer experience. 12. Primary constructors were added in C#12 and they are awesome. They allow you to move your constructor from here to here and tidy up your classes significantly. There is, however, a big problem with them. There is currently no support for defining read-only fields through a primary constructor. This means that if you want to inject a service in your class, which should fundamentally be defined as immutable with a read-only keyword, well, you can't do that. The problem is that IDEs will suggest this as a refactoring, but if you choose to use it, you will end up with fundamentally worse code. It's not a big problem, but it is a problem nonetheless, so be careful. 13. .NET 9 finally brings a new type of IDE in .NET called the UUID v7. Now, we already had the GUID struct in C# for years, but behind the scenes, a GUID is just a UUID v4 with a Microsoft spin to it, which aims to be as random as it gets to be used in places like databases without having to check if an item with this ID already exists. This, however, can cause fragmentation in some databases when used as a key, leading to performance issues. The new UUID v7 solves that by replacing the first few bytes of this this new GUID type with time-related data. This now means that using the GUID.createVersion7 method will create a sortable GUID, preventing the fragmentation and the need for third-party libraries that offer a similar experience. 14. Have you ever wondered what's the smallest valid C# program? Since the introduction of top-level statements in C#9, we no longer need to have the tedious public static void main string array args method in the program.cs. We can simply write our code as if we were already in the main method, and C# will figure out the rest of it for us. An empty file, however, isn't valid code, so what's the minimum acceptable code you can have in the program.cs? Well, it turns out the smallest valid C# program is this. Yep, that's it. 15. Many methods in C# such as database operations or delays using the task class accept a cancellation token. It's easy to create a token of your own, but it's not what you should be doing if you're building ASP.NET Core APIs. Instead, you should allow the framework to do its magic itself. In order to get a cancellation token specific to your request, simply add the cancellation token parameter on your API endpoint. Whether that's a controller action or a minimal API method, adding that special type will allow ASP.NET Core to give you a token specific to your request. So if a user cancels the request, any cascading process will also be cancelled. Just make sure to pass your cancellation token all the way down. 16. Defining a new collection in C# can be tedious. From a new array to a new list or even a new dictionary and immutable types, you have to write a lot of code and can get cluttered. This is until now. With the release of C#12, we got brand new collection initializers. Simply use 2 square brackets and voila! Your code will now compile and use appropriate collection initializer behind the scenes, leading to better and cleaner code. 17. Did you know that you don't need an ID's package manager to see which NuGet packages are outdated? Well, with a .NET-outdated CLI tool, you can do just that. Simply install the .NET-outdated tool globally and run the command .NET-outdated. You will immediately see outdated packages, and using the upgrade option of the tool, you can even upgrade them to the latest versions. Not only that, but it also supports version locking, so you don't accidentally upgrade to a package version that costs around $130 per developer per year. 18. I'm sure you've used lorem ipsum to generate fake text for your websites, but that's actually a pretty bad thing to do in software engineering. Lorem ipsum doesn't look realistic, I mean, who even speaks Latin, which is why skilled developers use a different approach. This approach is called waffle generation. By using a waffle generator as defined by Andrew Clark, you can generate customizable, realistic-looking text which mimics real-world usage and adapts to your requirements. To use it in .NET, simply install the waffle generator NuGet package and call the waffle engine class with the HTML, text, or even markdown method to generate realistic-looking fake text in any format you might need. Not only that, but with the bogus integration, you can define waffle for any property of your type. 19. The .NET Web Application class contains many methods, but the most important ones are run, use, and map. Do you know what the difference between them are? Well, it's pretty simple. Run is used to add a terminating pipeline middleware. Use is used for adding general middleware in the pipeline, while map can be used for mapping middleware to a specific request path. Keep in mind that the order in which these methods are called is very important. 20. Writing validation code is very easy nowadays with tools such as the built-in validation attributes or Fluent validation, but most people are not validating for a very important type of user input, and that is naughty strings. Naughty strings are a list of strings that can make your server crash, and they can even expose security vulnerabilities. Thankfully, there's an easy solution. Simply install the naughty strings NuGet package and use the naughty strings class to retrieve any type of naughty strings. Naughty strings can be validated primarily in QA and end-to-end tests, so I'd encourage you to download the package and run it against your own software to see how it reacts. 21. This must be the most cursed thing I've seen in C# for years, but it's actually pretty simple and genius. Want to pass values out of a string like this, but you don't want to write regex because, let's be honest, nobody knows how to write it? Don't worry, simply install the interpolated parser NuGet package and use interpolated parser.parse with an input string and a template string. By simply using string interpolation in the template, you can extract variables out of it and then use them wherever you want. This is ultimately reverse string interpolation, and it is equally genius and cursed. I love it.
I know I shouldn't, but I will.
22. C#12 introduces a new feature called alias anyType. This feature allows you to use the using directive to give an alias to any type in your project. This in return can fix 4 very important problems. First, it can simplify names when working with long or complicatedly named types. Second, it allows you to disambiguate types and resolve potential naming conflicts. Third, it enables you to define value tuple types that are intended to be shared in an assembly. And last but not least, it adds clarity to your code by using more descriptive names than what the original author used. 23. In most cases in C#, you should be using DateTimeOffset over datetime, and that's because datetime simply represents date and time, but unless this datetime is of kind UTC, it can refer to any time zone. This can be really bad for most business use cases in programming. That's where DateTimeOffset comes in. It doesn't simply represent date and time, but it also indicates how much that date and time differs from UTC, so it is always an exact moment in time. Given that everything in business has to do with client-relevant time zones, storing DateTimeOffset helps you avoid the ambiguity and errors that can arise from simply using unspecified kind date times. 24. Did you know that you don't have to make a billion projects in order to separate and limit which class can be used in which namespace? You can easily restrict bad class usage by introducing architecture tests into your solution. Just install the NetArchTest.rules NuGet package and use the Fluent Builder interface on the types class to limit anything from which classes can be used within which namespaces to which types should be sealed by default. Now your infrastructure or your application namespaces won't use the wrong classes in them, making sure that your policies are used by all developers.
25. Are you using Fluent extortions and assertions and you don't want to pay the $130 per developer per year fee? Here are a few options. 1. Pin version 7 and never move to a new version. The license change only applies to version 8 onwards, so given that Fluent Assertions is feature complete, just don't move to a new version. 2. Use Awesome Assertions. Awesome Assertions is a fork of the free version of Fluent Assertions, which is a drop-in replacement for your FA code. It seems like it will get more updates and features, so keep an eye on it. 3. Use Shoodly. Shoodly is a similar library to Fluent Assertions and it has been around for years. It largely offers the exact same functionality with a bit of a different wording. 26. Did you ever need to share the JSON schema of your object in .NET but didn't know how to do it because there is no built-in functionality? .NET 9 introduced a brand new feature for system.text.json called JSON Schema Exporter. Simply get the JSON Serializer options class and use the getJSONSchema node method using the tab you want to export. You can use custom JSON Serializer options as well as JSON Schema Exporter options to change the output to your exact use case. It is actually what the brand new OpenAPI functionality of .NET is based on. 27. For many years, .NET developers that wanted to use a multi-threaded loop had to use the for or for each methods of the parallel class, but it came with a massive problem. If you accidentally used the async keyword in the lambda, you made a massive mistake because you basically created an async void method, which is a big no-no. Thankfully, .NET 6 added the for async and for each async method on the parallel class, which can truly behave like an async task when the async keyword is used, and it's a great option for those who want to use parallelism and concurrency.
28. Do you have flaky tests and just can't be bothered to fix them? Okay, first of all, fix them. Flaky tests suck.
Subscribe for more .NET.
But if you don't want to do that, I have a solution for you. You can install a global CLI tool called .NET Retest, and from now on you can use the command .NET Retest to run your tests. .NET Retest will automatically retry your flaky tests for a couple of times if they fail, and they will hopefully pass the next time or two. Okay, but seriously, fix your tests.
Stop it. Get some help.
Subscribe for more bad advice. .NET tips. 29. The params keyword is a conceptually great way to pass down n amount of parameters on a method, but unfortunately it is limited only to array types and it comes with serious performance issues. That's until C# 13, where the params keyword got a massive upgrade. You can now use it with tons of enumerable types from lists to IEnumerable and my personal favorite, spawns. Not only that, but they're now significantly more performant and optimized. 30. Want to mess with your colleagues and produce a pretty insane bug in your code? Create a class file with a random name and name the class inside the file Monitor. By implementing an enter and exit method with these parameters, you can capture any object that is being used for locking purposes. Unfortunately, if you just run this code, it won't really do anything. But if you update the namespace of this Monitor class to be in system.threading, the compiler will use this class instead of the native Monitor monitor class of .NET, leading to the code stepping into the enter and exit methods of your own monitor class when executed. Legal disclaimer, this is a joke and not actual advice, please don't sue me. Subscribe for more non-legally binding .NET tips. 31. Have you ever wondered why the recommended and standard convention for private fields in .NET is to start with an underscore? The reason for this convention is because the underscore defines scope. In a world without the underscore, if we scroll down into a method of our class, we wouldn't know which variable is a global class defined variable and which one would be a method defined one. In an ideal world, you'd be able to see the entirety of the method body without scrolling, but this isn't an ideal world. You can use alternatives like this dot, but my recommendation would be to stick with the underscore. 32. You might be using the HTTP client wrong. For example, if you're creating a new HTTP client every time you're making a request, you're doing it wrong because you can cause socket exhaustion. If you're creating a static HTTP client and you keep reusing that, this solves the socket exhaustion issue, but because DNS is only resolved upon instantiation, if DNS changes, you're basically screwed. Instead, either use long-lived clients and set the pulled connection lifetime to a value that works for you, or create an HTTP client using the HttpClientFactory, which disposes the client itself but pulls the HTTP message handler, solving every DNS and socket exhaustion issue you might have. 33. Snapshot testing is a type of testing that validates the outcome of some action, but in a very unique way. Whether that's a class, JSON, text, or even an image or a web UI, snapshot testing using verify allows you to create a verified version of the outcome, and then every time the test is rerun, the test output is compared to that originally verified version. This is a very fun and robust way of testing, and is perfect to introduce in projects that don't have unit tests because it's not too invasive, but it is very effective. It works with any testing framework as well as many other libraries such as NT framework. 34. Tired of writing the same boring code over and over again when calling APIs? Well, thanks to Refit, you don't have to. Refit allows you to simply create an interface that contains one method per API request, and then by simply decorating that method with the appropriate attribute like get or post, it will create the rest of the code for you, no pun intended. Either use the REST-service.for method to create an instance of the appropriate interface, or simply use the HttpClientFactory extensions and you're good to go. 35. If you want to ensure that only one thread accesses a certain operation, you might rush to the log keyword, but if you try to do that with a code segment that includes an await keyword, you'll quickly find out that the compiler doesn't really like that. So what do? Well, you can simply use the semaphore slim class. Create an instance of the class as a static field and set its constructor values to 1 and 1. This ensures that only one thread can take the leash out of the semaphore. Then simply call wait async when locking is supposed to happen and open a try block. Add all the code you want to be thread safe in there, and then add a finally block which calls the semaphore release method. It's also wise to add a timeout on the wait async method just to make sure that nothing accidentally deadlocks. This way, only one thread will access this code at one time. 36. .NET 9 introduced a brand new type of GUID called GUID version 7, which is a time-sorted UUID v7 as per its spec. However, you don't have to upgrade to use it since solutions for this have already existed for years, and one of the most common ones is ULIDs or ULIDs. ULIDs are sortable randomly generated IDs that are extremely fast to create, like really fast, and can be used when you need sortable unique identifiers, which is extremely common in distributed systems and cloud computing. Simply install the ULID package and call the ULID.newULID method. You can even turn them back into a GUID if you need to use them in a method that accepts one. 37. If you have multiple asynchronous operations that don't depend on each other, don't use the await keyword in a serial fashion, since this will slow down your application's potential performance.
I've waited years. How many years?
Instead, get the tasks of these methods and await them all together using the Task.WhenAll method. This will allow all of them to be executed in parallel while still being asynchronously executed, significantly improving the performance of your application. You can also access the result property of the tasks directly after the WhenAll operation has completed, since the task will have computed at that time and there is no risk of any deadlocks. 38. Everyone knows what transient, scoped, and singleton lifetimes are in the .NET dependency injection container, but what many people don't know is that the scoped lifetime isn't limited to API requests. You have the power to create your own custom scopes for use cases like message processing by injecting the IAsyncEnumerable. Wow, that was a mouthful.
That's what she said.
Michael, please.
And by using the create scope method, you can get a service scope back, which allows you to access a service provider and get a service inside your own custom scope. Just make sure you dispose the scope when you want the scoped lifetime to stop existing. 39. Primary constructors in C# are really cool and can remove a lot of the code you'd normally have to write, but for me, they're just not there yet. First, you can't define them as read-only, so if you use them in a method which turns them into a field, anything in that method can change their value. This isn't a terrible thing and can be easily caught in code reviews, but it's annoying when IDEs suggest moving read-only fields to primary constructors because it's just changing the semantics, it's not what it was after the refactoring. Then, if you're using the underscore standardized naming for fields, it just feels wrong using camel case for primary constructor parameters and mixing them since they look like method variables. Overall, not very impressed with the implementation of the idea. 40. Working with unit measurements in C# is very confusing at times. Even the built-in conversions, where applicable, can be pretty tricky to use. That's why when working with units, I always use the units.net library. Units.net can be installed through NuGet, and it automatically adds tons of units and conversion capabilities to .NET. From meters to feet or RPM to torque, horsepower, and more, Units.net has explicit and implicit conversions to convert different units to whatever you need to use based on the application's needs. 41. One of the biggest problems with dependency injection in .NET is that it's runtime, not compile time, so any errors due to configuration problems or any other issues will only pop up when the application starts and ultimately fails. You can, however, configure the DI container to blow up early at build time, so you never risk deploying something that won't work. You can do that by setting the ValidateScopes and validate on build settings of the service provider to true. Now, any misconfiguration will make the build fail instead of failing when you run the project. 42. C# 14 is looking to add a brand new feature called the null conditional assignment. C# already has the null conditional operator in the form of a question mark and the dot to access a property or value when the operand evaluates as not null. However, there is no way to use null conditional operators and still set the value of the property if the operand is not null. C# 14 aims to fix that. You will now be able to have a null check using the null conditional operator like this, but also assign the value like this if the operand is not null. 43. C# 12 introduces a new and cleaner way to initialize the empty dictionary using just two square brackets. Did you know, however, that we already have two ways to set up a dictionary? We have the original add syntax from C# 3, but also the collection initializers method from C# 6. What you may not know is that these two methods are semantically different and can have unintended consequences if you are not aware of the differences. The add syntax will prevent multiple instances of the same key and throw an exception if encountered. However, the index initializer method will allow this and quietly overwrite the key value if defined multiple times. So be mindful with your
That's what she said. Don't you dare.
dictionary and choose wisely. 44. Both classes and records in C# have primary constructor support, but they work very differently. In a record, the primary constructor automatically creates public immutable properties. That means they're read-only and they're used for value-based equality. Now, for classes with a primary constructor, the parameters are in scope throughout the class and you can use them in methods or initializers. For example, you can write console.writeLine name inside a method using a primary constructor parameter, but there is no this.name or public name property unless you declare one. That being said, behind the scenes the compiler will create a secret field to store the value if it's used in a method. 45. What the hell is a refstruct in C# and why should you care?
But I do care.
Refstruct is a special kind of struct that must stay on the stack at all times. That means it's super fast and super safe for high-performance scenarios. You've probably already used one. Span of t is a refstruct. It gives you blazing fast access to slices of memory without any allocations. However, there's a massive catch. Refstructs have very strict rules. You can't box them, you can't use them in async methods, and you can't store them on the heap, not even in fields of normal classes. Why? Because they deal with memory directly, and putting them on the heap would break safety. This makes them perfect for processing large data, parsing, or manipulating memory with zero allocations. 46. Ever seen a method parameter with the in keyword in C# and wonder what it actually does? The most common use case for the in keyword is that it lets you pass structs by reference, but it makes them read only inside that method. Why? Because performance.
Good performance.
Copying big structs can be very expensive. The in keyword avoids that by passing a reference, just like ref, but with a safety net. The method can't modify it. Just one catch though. If your struct isn't marked as read-only, C# might create hidden defensive copies when you access its members. This can really hurt performance. As an extra tip, combine in with read-only struct or read-only members to unlock the real performance boost. 47. Have you ever used Linq and got a weird bug where the data changes after the query? That's deferred execution in action. Linq methods like where, select, and take won't run right away. They just build a query like a blueprint. That means you can keep adding to your query, for example conditionally, even after it's declared. When you finally run it, C# compiles it into a single optimized operation, taking into account all the methods used. But beware, if your data changes before execution, it shows up in the results. Linq is lazy by design and powerful when you know the rules. 48. Want zero allocation, insanely fast memory in C#? Say hello to Stackalloc.
Hello there, little fella.
Stackalloc lets you allocate arrays on the stack, not the heap, which means no garbage collection and crazy fast performance. Just like that, you get a block of memory of 5 integers living on the stack, and the moment this method ends, this memory is completely gone without any garbage collection. That's because the stack frame is discarded. This is huge for things like game dev, parsing, or high-performance code, because it means the garbage collection doesn't have to do extra work, which leads to pausing in our applications and inconsistent throughput. But there's a catch. Stack space is limited. Too big and your application will crash with stack overflow.
Keep your hands off my stack.
49. A delegate in C# is like a function pointer. It lets you store and pass around methods as variables. Delegates power events, callbacks, and async flow in C#. But did you know that C# has several built-in delegate types? First, we have func. This is used for methods which return a value, and the last type parameter is a return type for the func. Then we have predicate, which specifically returns a boolean. This is basically a func of t that returns a boolean, and it's object used for filtering logic. It was introduced before func was a thing, and nowadays you should be using func of t of type bool. Finally, we have action, which is just used for methods that return void. Despite it being the most hated feature of the lead C# designer, Mats Torkensen,
you have a function type that is also the collection type. Yeah. I hate them.
You can also chain delegates together. That's called the multicast delegate, which lets you invoke multiple methods in a sequence with one call. What sequence? Well, good luck. 50. Did you know that in C# there's a number of ways for your base class behavior to get overridden by the derived class? First, we have abstract methods. These must be overridden. The base class has no logic, you're forced to define it in every derived class. Then we have virtual methods. These give a default implementation, but will let you override them if needed. Also, any method that overrides a virtual one is itself virtual, unless you seal it. Interface methods, they're implicitly virtual too, and in C# 8 and up, interface can also have default implementations. Those act like virtual methods when called via the interface. And finally, we have method hiding using the new keyword. This doesn't override the base method, it just replaces it in the derived class when accessed through the derived type. But be careful, if you call it through the base class reference, you'll still get the original method. 51. Want to skip garbage collection and reuse arrays?
I'd love to skip that part.
Use ArrayPool.Shared. It's like a memory recycling bin. You rent an array when you need it, and you give it back when you're done. For example, use shared.rent to rent a block of memory, and you can use it like a normal array, but just remember, it might be bigger than you ask for, so make sure you request as much as you think you need. When you're done, just return it to the pool using the return method. This avoids allocating new arrays every time, which is perfect for high-performance scenarios like JSON parsing, file I/O, or handling thousands of requests per second. Just make sure you always return what you rent, and if you're storing sensitive data in that array, pass clear array as true when returning. 52. Async void is basically a booby trap. Avoid it. Why? Because async void methods can't be properly awaited the same way an async task can. This means no error handling, no control flow, and no way to know when you're done. For example, having an async void method like this, where an exception is thrown inside, will cause the application to crash. So when is async void okay? Only in one place. Event handlers. Event handlers don't return tasks, so async void is the only option here. And that's fine as long as you handle exceptions inside. 53. Ever seen null exclamation mark in C# and thought, what the hell is the exclamation mark doing after a null?
What the hell is that?
It's called the null-forgiving operator, and it tells the compiler, relax, I know that this won't be null at runtime. You can use it with the null when you don't know what the value would be, or you can use the default keyword. Why use it? Because with nullable reference types enabled, C# wants proof that a non-nullable property is initialized. If you know it's going to be set later by the framework constructor or the serializer, just use null exclamation mark to silence the warning without changing the type. 54. Think using is just a shortcut for cleaning up? There's actually more going on behind the scenes. Using is a contract. It tells the compiler, hey, when I'm done with this, call dispose for me. As soon as a block like this, for example, ends, dispose is called. Even if there's an exception, there will always be a dispose call. This is perfect for disposing things like files, streams, database connections, timers, and much, much more. And since C# 8, we can actually have using without any braces where the scope is implied. We can even use it in an async context. We can have an await using when we're working with an IAsync disposable. It might be simple lowering where the compiler translates using into a try finally block, but it can make our code look way cleaner when we have complex disposing operation. 55. The with keyword in C# is honestly one of the coolest features for clean and safe code. It lets you clone an existing object and change just what you need without touching the original. Take this for example. Now you've got a brand new person object with updated age and the same name, and the original person stays completely unchanged. This is perfect for immutable types where once you create an object, you don't want anyone accidentally modifying it later. With was made for record types, and starting with C#10, it works for structs too. Under the hood, C# auto-generates a clone method for records, so the with just handles it for you. Of course, cloning a class will reallocate it given it's a reference type, so be careful with memory allocations. 56. In C#14, extension methods are becoming obsolete. Well, kind of. Now you'll be able to add static methods, instance properties, and static properties to any existing type, all without modifying the original source code. Even if you don't own that object, you'll be able to add all those things. This means you can enhance any type with new functionality, making your code more expressive and modular. Take this for example. Here we added an instance method and a static property as well as a normal property, and all this just works because we're using the preview version of C#14. Just make sure that if you adopt this feature, migrate all your existing extension methods into this new feature so you don't have two things to keep track of. 57. Tired of writing new list of type int 1, 2, 3 over and over again? Well, C# has your back because now we have something called collection expressions. This old syntax becomes like this now. That's it. No list of type t, no add calls, just square brackets, just like JavaScript or Python, which I don't know if that's a good thing or not, but we're getting it anyway. Want to combine collections? Just use a spread operator. Collection expressions are a great feature, and I'm sure those who hate var will love it.
Get out of my sight!
58. Ever use the params keyword to pass a variable number of arguments into a method? It's super handy, but it usually means a heap allocation. But that is no longer a problem because in C#13, we got span support for params. Given that the span can only be allocated on the stack, you will save that heap allocation, making your application more memory efficient and faster. So don't worry anymore, just use the params keyword, it's safe to use. 59. Ever get tired of writing the same type twice when creating objects? C#9 fixes that with target typed new. Now you can just write this. The compiler already knows the type from the left-hand side, so you don't have to repeat it to the right. This works with constructors, collections, and even generics. It keeps your code cleaner, especially in complex declarations. 60. Remember writing public static void main string array args just to print one line in C#? Well, C#9 said, let's skip that.
How about no?
Now you can just have this. That's a full valid program now. No class, no main method. Just type your code at the top level. The compiler will actually wrap it into a class and a method behind the scenes, but you don't have to carry that ceremony. It even works with async await. Just a heads up, you can only have one top level file per project. It now becomes your entry point. 61. C# pattern matching just got way smarter. You can now use not, and or just like this. This will let you write more expressive and declarative code, no more nested if statements or confusing conditions. Use not to exclude patterns, or to match any multiple cases, and to combine conditions in a single line. You can even use it inside checks like this. This is not just a switch, this can be used in many places. 62. Still using hard-coded strings to represent code-related things in your code? That's a recipe for bugs. Take this for example. What if you rename user ID later? That string won't update, and now you've got a silent bug. Here's the fix. Use name of. Name of returns the actual name of the symbol, so if you rename it, your code updates automatically. It's perfect for logging, validation, exceptions, and attributes, so please use it. 63. Did you know you can define your own deconstruct method on any type in C#, not just records? That is right. You can have a class like this, and now by adding a deconstruct method, you can do this. Want more options? Just add another deconstruct overload and it will work. That way you can deconstruct objects that make sense into other objects without having to carry the entire object out. 64. Since C#10, you can do something wild. You can add attributes to lambda expressions like this. Why would you want to do that? Because attributes can add metadata or change behavior, even on inline code. It's especially useful when you're using lambdas for source generators, middleware, custom analyzers, or even interop scenarios. Under the hood, C# compiles lambdas into methods, and now you can add attributes to those methods just like regular ones. It works with static lambdas too. 65. In modern C#, you can do more things than just check types with is. You can check ranges too. Here's an example. Yep, no need for x more than 0 ++ x less than 100, just write it the pattern matching way. You can use any bigger than, smaller than, and so on, and combine them with and, or, and not. It even works with switch statements like this one. 66. Still checking for null and throwing argument null exception like this? Well, C#10 makes it cleaner with throw if null. Now you can use the argument null expression.throwIfNull method and pass your input, and that's it. One line, no boilerplate. The method name even tells you exactly what's happening. It throws if the argument is null using name of input automatically, so you don't accidentally pass the wrong thing in the method. This leads to clear constructors, services, and method guards, which is most of the places where null checks like this were cluttering your code. 67. You've seen expression-bodied methods and properties like this one, but did you know you can do this with constructors too? Here's this, for example. That's a full constructor. No braces, no boilerplate. It's perfect for simple types like small classes or small structs, where all you're doing is just assigning some values. However, this syntax can be a bit ugly, so make sure you fold your code properly to not lead to some very long declarations. 68. When you write a tuple in C#, it looks simple like this. But under the hood, this is not a tuple. It's a value tuple. Value tuple is a struct, not a class, which means it's lightweight and location free. Before C#7, we used tuple of T1 and T2, which lives on the heap and can't use named fields. Now with value tuple, you can write this. This gives you named fields, pattern matching, and better performance with no extra syntax or classes. It's one of my favorite C# features. I highly recommend you use it. .NET Tips Part 69.
Did you know that C# has many interesting keywords? For example, something can be declared as in and out. This is barely legal and the compiler won't let you in this variable. The size of it might be short, but you can finally try and catch it. It would need to be double for it to be long.
Delightful.
You can treat it as an object, but try not to break it. Just make sure this event is not public. In any case, make sure it's protected. Subscribe for just the tip.
70. You've seen ref and in method parameters, but what happens when you combine them? Turns out it's totally legal to pass a ref variable to an in parameter, just like this one. But wait, ref to in? Isn't that a mismatch? Well, here's the trick. In means read only by ref. Ref just says this is a by ref variable. So the compiler says, oh, I can treat this as a read-only reference, but the reverse doesn't work. You can't pass an in parameter to a ref method because ref means the method might write to it. Bottom line, passing ref into in is legal, but passing into ref is a no-go. 71. Did you know you can compare tuples in C# like this? Yep. No need to compare each value manually. C# compares tuples element by element in order. It works because tuple implements the equals and not equals operators and even the equals method. So this is totally valid too. Just a heads up, names don't affect equality. Only values matter. 72. Want your methods to automatically know who called them without using reflection and slow your application down? C# gives you exactly that with the caller member name attribute. Just apply it like this to a method parameter and set it as a default string. Now, whenever you call this method, it automatically fills in the method name at compile time. No need to hardcode any strings and no risk of forgetting to update them if you rename the method later. It's perfect for many things like logging, property change notifications, as well as debugging. There's also caller file path and caller line number that gives you the file path and line number respectively. The caller attributes are great to get metadata without the use of reflection, so I highly recommend them. 73. C# has some hidden gems, attributes that tell the compiler more about your code. For example, not null tells the compiler a parameter won't be null after the method runs. Or does not return is used to mark methods that will never return. This helps the compiler understand flow with no more warnings after throw. It knows this path ends here. There's also maybe null, which tells the compiler that the method might return null, as well as not null when true, which is a smart null check tied to return values. These attributes are great to make your intent clear, and it helps the compiler get smarter. 74. Some devs love var, but others hate it. So why the drama? Because var can hide the type, and that makes your code harder to read, especially with complex unfamiliar libraries. Take this for example. Now, imagine you're debugging. You have no idea what data actually is. By using var, you just lost clarity. But here's the truth. var is great when the type is obvious. Take this for example. You know that this is a string and you know that this is a person. Avoid var when it hides meaning and use var when it reduces noise. It's not about style and opinions, it's about readability and intent. 75. C# gives you a dynamic keyword and most of the time you should just pretend it doesn't exist. Take this for example. Looks flexible. It is, but it comes at a price. You lose type checking, performance, and refactor safety. Misspelling a property, the compiler won't help. You'll just get a runtime exception instead, and at that point it's too late. It's also slower. Every dynamic call uses a DLR, which is a dynamic language runtime, which does a lot of nasty things under the hood.
Lord have mercy, is that what that is?
So when is dynamic okay? Well, comment interrupt, working with JSON or expando object when you're doing something ad hoc, or talking to a scripting engine like Python or JavaScript. Effectively glue code. But in your app logic, no. Use strong typing, use interfaces, use records, use classes, use real objects. Dynamic is a parachute, not a pattern. 76. Some devs still write C# like this. And it looks fine, but it really isn't. You're using exceptions for normal logic. And that's bad design. Exceptions are expensive. They create stack traces, hit the GC, and slow everything down. Worse, they hide your intent. You're saying something went wrong when really you just want to check if a user exists. Do this instead. Exceptions are for errors and exceptional cases, not expected conditions. If it's not exceptional, don't throw. 77. If you write a unit test like this, just don't. It compiles, but you just made a massive mistake. Your test framework can't track that method. Async void doesn't return a task, so XUnit, NUnit, or MSTest will run it and just move on, even if the code inside hasn't finished yet. Worse, if an exception is thrown, the test runner might miss it completely. To fix it, always return a task. Every major testing framework works like this. Async void is for event handlers only, never for tests and never for logic. 78. If your code looks like this, you're not organizing your code, you're hiding it. Region is like folding laundry and shoving it under the bed. It looks clean, but it's still a mess. The real fix? Break up the file or organize it better with methods. Split large classes into smaller ones, extract logic into focused components. Need to separate methods? Maybe those methods don't belong together. If you need region to manage your code, your class probably has too many responsibilities. Region isn't structure, is a band-aid. Structure your code so it doesn't need folding tricks. And worst of all, it only works on IDs. If someone is reviewing your code on GitHub, this is of no use and your code still looks like a mess. 79. Adding the obsolete attribute in C# looks responsible, right? Well, here's the truth. If you don't plan to remove that method, you're just generating warning noise. Dev teams see the warning and ignore it. Then it sits in production for years. The warning becomes meaningless and your code becomes full of, meh, we'll fix it later. So when should you use obsolete? When you're deprecating for real, when you're scheduled for removal, when there's a clear, tested replacement. Otherwise, leave it alone or just use a comment. 80. Do you know you can now run a C# file directly from the console without creating a full project? That's right. Just do .NET run app.cs and that's it. Just a single file, nothing else, no boilerplate. You can also add this on top of your file to configure it. SDK specifies the SDK you want to use and package can use a package which can be restored by NuGet. You can even use shebang syntax to make it executable just like this. Now give it permissions like that and voila, just use app.cs and it will run. 81. Tired of writing the same using statements in every file? Well, from C#10 you can move those into one place, a global using.cs file. Now every file in your project gets those for free with no more repetitive using statements. It also works with both namespaces and static imports. Just make sure you don't statically import something that might look a bit weird. 82. Think nameof is some kind of reflection? No, it's actually way faster. Here's an example. Nameof input just returns the string input and the compiler resolves it at compile time. That means no runtime cost, no memory allocations, and no performance hit. Compare that to a getType.name or reflection APIs. Those run at runtime and significantly cost performance and can also break some AOT scenarios. Use nameof safely. 83. Got internal classes or methods that you want to test? You don't have to make them public. Instead, use the internals visible to attribute. You can apply it like this on a file like assembly.cs or directly to the CS proj by using either an assembly attribute or use the more modern internals visible to parameter and voila. Now your test project can access internal members and don't confuse that with private members, that's completely different. Private members should be tested to their public members, but internal members are internal to everyone else but public to you. 84. Did writing exception handling like this? Well, you can actually clean all that up with when filters. Here, we're catching a HTTP exception and we're using a when filter to say that we only care about status code 404. Way clearer without any if statements in the catch clause. 85. You might have used where t should be a class or where t should be a struct in generics, but have you tried this, where you have where t should be not null? Not null means exactly what it says. This type can't be null. It works with both reference types and non-nullable value types. So string, int, and datetime, they all work. However, if you have a nullable string, nullable integer, and so on, this won't work. This lets you write safe, null-free APIs without forcing a struct or a class split. It's great for things like dictionary keys, IDs, and value objects, and I recommend it to everyone doing sophisticated stuff with generics. 86. You've seen scoped in dependency injection, but in C#12, scoped becomes part of the language. Here, for example, scoped means this value must not outlive the caller. No heap, no capture, no accidental escape. It's perfect for working with stack-only types like spanf or refstruct, and it protects you from writing code that compiles but would crash the runtime. It's not just for parameters, you can use it here with ref locals too. Think of it as a lifetime fence, and the compiler enforces scope safety for you. 87. In C#, destructors exist, but they're not what most people think. Here's an example of the syntax. It's called a finalizer, and it runs when the garbage collector decides your object is done. But here's the catch. You don't control when it runs, it doesn't run on app shutdown, it runs on a background thread with no guarantees. And even worse, adding a finalizer makes GC slower, and it has to track your object in a special queue. So when should you use it? Well, almost never. Prefer iDisposable for simple disposal. Only use destructors to release unmanaged resources in case dispose was never called. 88. Ever write code like this? Well, you don't have to. You can clean that up with property patterns. No null checks, no nested ifs. You match deep inside the object, right in the condition. You can also match values like this, or combine patterns for complex conditions like this. Now, is that more readable and does it look like C#? I'm gonna let that for you to decide. 89. C#11 introduced list patterns, and they let you match arrays and lists by shape. This example checks if the list has exactly 3 elements, 1, 2, and 3. You can also match parts and ignore the rest. Double dot means any number of elements, like a wildcard. Want to catch the last element? Do it like this. Why not both? Do it like this. It's a bit limited in functionality, but it's great to know that it's there. 90. You've probably seen override, but what about this? Yep, that's a sealed override, and it basically means this override can't be overridden again. So if a base class defines a virtual method and you override it in the subclass, you can lock it down with sealed without sealing the entire class. This leads to prevention of unexpected behavior in future derived classes. It's especially useful when you write framework or library code. 91. Let's say you want to parse a number. Do you write this using int.parse or something like this with int.tryParse? Try methods don't throw. They give you clean control flow, no exceptions, no surprises. This isn't just for numbers. Use this pattern in your own code too. When I write a method that parses something tricky, add the try suffix, return a boolean, and have an out parameter. No try catch, no stack trace. Just fast and predictable logic. For 92. Want to try the latest C# features before they officially ship? You can, using Lang version preview in the CS proj, just like that. Now you can write C# code using the latest features from the next version, like extension members and discriminated they will never ship. This is excellent for trying out features and providing feedback, but keep in mind those might change before the version is released. 93. Want the last item in an array in a performant way, so do not use .last? Well, you don't need .length -1 anymore. You can now use the _1 syntax, which means the item 1 from the end. So _2 is the second to last, _3 is the third to last, and so on. It's called index from end, and it's super clean, if not a bit hard to read. It works with arrays, spans, and strings, basically anything that supports slicing. 94. Need an empty array? You've probably written something like this using Array.Empty, but now you can just write this. That's right, the empty square brackets array literal is now fully optimized. Under the hood, it reuses the exact same static instance just like Array.Empty, so you get the exact same performance, but it's cleaner and more readable. 95. Need to iterate asynchronous data like paginated APIs or file streams? You don't need a loop full of await statements anymore. Just use await for each. This method, for example, returns an IAsyncEnumerable of t, a stream you can consume as it arrives. No buffering, no blocking, no magic. It's perfect for large datasets, message queues, or reactive pipelines. And yes, it handles cancellation too. 96. Do you think code like this is safe where you say int.maxValue and you add one value? Well, wrong. That doesn't throw an error. It wraps around to a negative number silently. But you can catch that with a checked keyword. Here's an example. Checked here forces the runtime to validate your math, and if it overflows, it throws. You can even wrap entire blocks of code like this. So when should you use it? Well, financial calculations, physics sims, or anything where math bugs is real bugs. 97. Check this out. In C# you can have two anonymous objects like this with the exact same values. Do you think A double equals B? Nope, that checks reference equality. But A dot equals B is true. Why? Because anonymous types in C# automatically override the equals method and the getHashCode method based on property values. So even though A and B are different objects, they're treated as equal if the contents match. This is perfect for temporary data structures like grouping in Linq or comparisons without writing boilerplate. 98. Ever seen async code like this? Task.yield doesn't wait. It just tells the runtime, pause here and resume later. This means return control to the caller, avoid blocking, and let the UI or event loop breathe. It's perfect when you want to yield back to the UI thread, or prevent a long-running method from visiting the application, or even breaking up synchronous work into async chunks. But it doesn't delay like Task.delay. No timers, no sleeping, just a context switch. 99. Trying to squeeze every ounce of performance out of your code? Let's talk about inlining. Small methods are often inlined by the JIT, meaning the call gets replaced by the method's body. No call stack, no overhead. But sometimes the JIT won't inline unless you nudge it. This, for example, tells the compiler, inline this if at all possible. It's great for macro-optimized libraries, math-heavy loops, or hot paths. But don't slap it everywhere. Inlining large methods can hurt performance and code size. 100. Still writing regex like this? Well, that compiles at runtime and still costs memory. From .NET 7 onwards, you can generate regex at compile time like this. Then, just call this and voila, you have normal regex. No allocations, no JIT delay. The regex is baked into your assembly. It's fast, reusable, and totally static. Subscribe for more .NET tips.